Hello, everyone. Can you hear me well?
Hello, welcome.
So I think we're gonna wait a little bit for people to connect. Okay, maybe I think we can get started. Hello and welcome everyone. With me is Laurine Schmidt, our expert on the Geotrend platform, in charge of onboarding our key accounts, as well as our services expert responsible for the research department. I am Marine Tutoré. I am a key account manager at Geotrend. We are both in the same customer team, and we work in tandem with Laurine to support our clients. So before giving the floor to Laurine, a few words about Geotrend. So Geotrend is a market and technology intelligence platform powered by AI to simplify and accelerate access to all information about any ecosystem. So competitors, partners, emerging markets, innovations, patents, etc., allowing rapid, relevant, and global decision making. So you may have been following our news. We've just joined the SHAPS Vision Group, a specialist in sovereign data processing. This exciting news represents a unique opportunity to strengthen our position and accelerate our growth as a key player in the field of economical and strategic intelligence. Okay, during the presentation of our exploratory study on additive manufacturing, feel free to ask any question you may have in the chat, and we'll come back to this at the end of the session. I now hand over to Laurine, and enjoy.
Thank you, Marine. So today we are going to talk about 3D printing. Indeed, 3D printing changed the production world and all the industry fields, automotive, aerospace, energy, defense, and many others. We will focus on three specific industries: automotive, aerospace, and nuclear. The aim of this study is to present the organization of the market with economical and also technological vision of the ecosystem. We collect information through Geotrend with open sources and patents information coming from EspaceNet database. All researches have been done in English, and as you will see later, during all the presentation, I will talk about two metrics: the number of documents, which represents the intensity of communication, and the power of the ecosystem based on the number of relationships detected. Let's start with a few key facts about the markets. So additive manufacturing market is in expansion with a growth rate expected to 20.8 from 2020 to 2030. The industrial 3D printer segment dominated the market and represented in 2021 a revenue share of more than 63%. Industrial 3D printers are being adopted extensively across various industries for applications such as prototyping, designing, or tooling. And this market is very dynamic. And for example, one way to prove it is the last deal in May between Desktop Metal and Stratasys over $1.8 billion. To quickly understand and visualize 3D printing market, we can see an ecosystem overview with the 3D printing pure players and the manufacturers of many industry, and also the different relationship existing between these entities. Here we present in the first graph the repartition of the communication by industries. Aerospace, energy, and automotive dominate the market in terms of communication. Then on the right, there is a timeline with the evolution of communication about 3D printing since 2012. The healthcare industry is a recent industry which communicates in 3D printing. And there is a peak of communication in 2019 impacted by the growth of metal 3D printing, and big company expanded their strategy in 3D printing, such as Siemens. We are sure that this growth of communication will continue to evolve as the 3D printing industry is in total expansion. Then we rank industry in terms of communications and the power of their ecosystem. This graph enables us to notice that energy and aerospace are the sectors the most predominant on this criterion, followed by automotive and defense. Concerning the materials, metal is one of the most common materials used in the additive manufacturing process. Also a bit more pricey than the other materials, it's great for designing or creating industrial parts. Steel and titanium seems to be more common, and ceramics are one of the newest materials to enter in the market. They have several advantages over both metal and plastics due to their ability to resist immense heat or pressure without breaking or distortion. Plastics, thermoplastics, or also known as polymers, are another common materials used in additive manufacturing and come with a lighter price. The US are so far the country with the most communications about 3D printing. We can assume that they rule the global 3D printing industry. For example, the United States Department of Defense allocated funds for the innovation and development of this technology. Even big companies like HP, Microsoft, and Autodesk have made additive manufacturing processes more accessible. And Chinese firms usually invest in creating and studying this technology because they see it as a chance to develop their industrial sector. However, the top 10 markets also include large European manufacturing countries such as Spain, Germany, Italy, and France, of course. Now we will go deeper into three main industries. Let's begin with automotive. So the automotive 3D printing market was valued at around $3 billion last year, which represents around 25% of the market share. Here we detect the main actors in the automotive industry using 3D printing. We have two categories: the pure players in white side, the most active. So the pure player is the most active, like Stratasys and 3D Systems, and the automotive manufacturers in the other hand. We noticed BMW, which communicates a little bit more than Ford on this subject, but its network is less important than Ford. Manufacturers invest in 3D printing and deal strategic partnership to expand the usage. For example, this year, BMW is in the process of increasing the use of 3D printing thanks to the partnership with Geotrend, a nylon 3D printing specialist company. Some example of a recent partnership and investment throughout the world. So, for example, recent information concerning Peugeot. So, information come from France, where we have Peugeot integrate Stratasys 3D printing technology for their electronic vehicle interior design. And we also have information come from Germany with Voxeljet, a 3D printing company, which develop additive manufacturing in BMW plant in Germany. So automotive is the fastest growing sector using additive manufacturing. However, it's one of the most advanced sectors where many applications are already in use and the competition between automakers is very noticeable. First, prototyping has historically been the most common use case for 3D printing in the automotive industry. With 3D printing, designers can quickly make a prototype of a physical part, from a single interior element to a dashboard or even a scale model of an entire car. Fast prototyping enables companies to turn ideas into convincing proof of concept. All manufacturers use prototyping in their production activities. Then we have molding. Indeed, 3D printing can reduce cost, increase efficiency, and produce low-volume tooling for traditional manufacturing processes like injection molding or thermoforming. And reparation and customization are less common usage. Ford is the only manufacturer which uses 3D printing in all usage. BMW is one of the early adopters of additive manufacturing. However, it's the most communicator on the subject. Last year, it announced the successful result of an additive manufacturing project for an automated metal 3D printing production line, which is capable of producing 50,000 parts per year. Now I will talk about aerospace. So aerospace was a very early adopter of 3D printing and still continues to contribute heavily to its development. 3D printing is changing aircraft production, and in 2022, aerospace additive manufacturing market represented around 20% of the market, so just behind automotive markets. Here we rank only private companies. That is why you don't see NASA, for example. The pure players dominated the global aerospace market with Stratasys and 3D system on the top. Airbus and Boeing are the key manufacturers in this ecosystem, using 3D printing, of course. Major organizations have already invested in 3D printing technology to decrease, not decrease, weight of the aircraft and enable greater versatility and speed on production lines. Here there is some recent example of partnership throughout our world. So, for example, this year in US, Fortify, a 3D printing firm, raised $12.5 million from Lockheed Martin and Recent Technologies. And we have in France this year again Airbus and Oerlikon, a Swiss 3D printing firm, which deal together 3.8 million euro for serial 3D printing satellite parts. Concerning the different usages, prototype is still the first usage. It enables the designers to refine the form and fit of finished parts in the aerospace market. The second usage is the production of complex parts. In aerospace manufacturing, different parts will require different tooling settings, which are complex. And 3D printing enables to produce these complex parts and reduce the expenses and the time taken. And finally, I would like to focus on the spare parts. Indeed, weight is a crucial factor in reducing the environmental impact of flying. 3D printed spare parts help reduce aircraft air drag, which reduces fuel consumption. All manufacturers develop prototypes with 3D printing. Airbus is more developed in all usage. As an example, it invests in 3D printing technology thanks to partnership, but also Airbus installs their own machines to create spare parts in titanium, in particular for creating complex parts. The last sector studied today is nuclear, which is part of the energy industry. Energy is one of the sectors where additive manufacturing has had an increasing role. The nuclear power plant industry has been gaining in predominance lately. With this rise in popularity, it makes sense as well that the sector is also turning to new technologies, including additive manufacturing. Here, vertical printers are still very active in this sector. But here, 3D systems seems the most communicators in nuclear compared to the other markets, where Stratasys was always on the top player. Many private companies are also investing in this technology, such as Siemens, Framatome, Hitachi, and others. Westinghouse Electric Company was a first in the industry using 3D printing for functional parts in nuclear reactor and still very active in this market, as we can see with its position in this graph. Again, here some recent partnership. So in France, we can see Framatome and ORNL partner to demonstrate the capabilities of a 3D printing reactor parts. And in Russia, this year, Rosatom, a Russian nuclear company, launches a Russian largest 3D printer. Regarding the usages, prototype is still an important part of the usage. However, on the contrary to the other industry, not all companies communicate on the prototyping. However, testing is a main usage and all the manufacturers communicate on. Another interesting usage is the production of complex components. Indeed, 3D printing is interesting for the nuclear industry as they enable the realization of complex design while improving the quality and safety of components and reducing the time and cost involved in their manufacture. Last application is the reparation of equipment or replacement of parts in existing plants. Westinghouse seems to be the only company which communicates about all the main usage of 3D printing in this industry. To continue our exploratory, we analyze patent deposits in 3D printing technology in the three sectors we study: automotive, aerospace, and nuclear. We used three specific keywords to describe 3D printing: three-dimensional printing, 3D printing, and additive manufacturing. We collected 674 patents filed between 2008 and 2022. In the following ranking of companies, we withdraw Chinese actors to have a vision of European and American patents. A specific analysis could be interesting to focus on Chinese patents. We focus on the 3 industries we study today, and we selected the top 3 applicants for each. Ford, General Motors, and Toyota in the automotive market, Boeing, Airbus, and GKN Aerospace for the aerospace market, and UT Battle, Capco, and a collaboration between General Electric and Hitachi for nuclear market. Globally, we found the same actors in terms of patent deposit and economical communication, except for nuclear, where UT Battle and Capco are the main applicants. UT Battle, for your information, is a limited liability company that manages the ORNL for the US Department of Energy, and concerning Capco, is a Korean electrical company which invests in 3D printing for power plant components. Other companies filed patents concerning the material, still focused on the 3 industry study. We found metal engineering companies and chemical companies such as Solvay for polymers and plastic. And of course, we collect information about 3D printers, but we were surprised to not have Stratasys and 3D System on the top. Stratasys filed only 1 patent in 2018, and we found none for 3D System in the sector we study. I specify it. We have a look on geography repartition, and without surprise, Chinese patents represent the majority of deposits, followed by the USA and UK. To finish with technical analysis, we highlight 3 recent topics for each industry. One for each industry, sorry. And we have Airbus filed a patent about aeronautical structure, Toyota concerning augmented reality, and UT Battle about 3D printed features on nuclear fuel cladding for optimized heat transfer. And now, what next? What next for the future for additive manufacturing? We were curious to understand which sectors are the most popular by the pure players in terms of communication. And it seems that they are all involved in the automotive industry. And to finish, we have a look on sustainability and 3D printing. Sustainability is becoming a strategic focus for the use of 3D printing. Additive manufacturing enables businesses to reduce, reuse, repurpose, and recycle. In this graph, we notice that aerospace, automotive, and energy are talking about sustainability thanks to 3D printing. But new companies are emerging in this ecosystem, such as CMS, Siemens, HP, and Henkel. There are also 3D printers specialists in sustainability as Surat, engaged in green transitions for manufacturing. 3D printing, to conclude, will continue to help companies to innovate and produce in a more sustainable way in the coming year. Thank you for your attention, and we are pleased with Marine to receive all your questions right now.
Thank you, Laurine. So actually, we already have questions. So one from Annabelle is there a way to visually group the actors thematically, like you showed at the beginning on the ecosystem mapping, directly on Geotrend, or do you have to do that outside of the tool?
Okay, like group together the actor by thematic. I think that's the question. Okay. No, Annabelle, we do it like directly on the PowerPoint. We just do. I hope I answer right your question, but we did a screenshot of the ecosystem, like the graph in Geotrend, and we had directly the name of the thematic on the PowerPoint.
Yeah, the thing is, the way you're gonna order or you're gonna group the actors depends a lot on maybe your company, like your culture and so on. So that's why it's not automatically done. But for sure, our research and development team, they always work to try to help you to do it automatically. For example, one thing we are working on is it a public actor or private actor? That is the kind of information we try to add on our ecosystems automatically. But for the moment, you have to do it on your own, and because also it's one of the way you're gonna add your own analysis on the ecosystem. This is the let's say a way to qualify the information, but also I think there is another part of the answer, and it's more like the way you're gonna display the information. And for sure, yes, we have ideas to help you to make it directly in the platform and not on PowerPoint. Okay, I hope we answered your question, Annabelle. We have another question from Gregors. How do you measure the power of ecosystem?
Yes. So the power of the ecosystem is represented by the number of relationships we detected in the communication, in the document. So more there is relationship concerning an entity, a company, the more its network is network is important.
Yeah. Then we have another question from Boris. Yes. General Electric Hitachi is a Canadian company, no?
No, Boris. But I'm not a specialist concerning the partnership between General Electric and Hitachi. But what I know, so Hitachi is Japanese company. General Electric is American, and this partnership is American. It seems to be American, but
at least the headquarters is in the US.
Exactly.
Okay, another question from Gregors. What is the analysis of use cases based on? I think it was concerning a patent analysis, but I'm not sure.
For the patent, we did not focus on specific use case. It was global. But for the use case we mentioned for each sectors, like the prototyping, the tooling, the modeling, it was based on the information we collect, the document we collect, and the use case. How can I say? More we detect a use case, more we assume it was an important usage in 3D printing.
Okay, thank you. And another question from Boris. Laurine, what is the time you spent between analyzing the Geotrend data and summarizing your presentation?
Okay. I have prepared this for you because I was imagining this question could be asked. There is different step. So the acculturation and ideation, because we are not expert on 3D printing, of course. So that take a little bit time. Then we launch the mapping, the research in Geotrend, and we collect all the data. After we have an important time in data analysis, of course. So we create a database, we analyze all the statistics, and after we have to write this report. We present it to you, and you have to count around 1 week of work for doing this with Geotrend.
Okay, thank you. Another question. Are there synergies planned between Geotrend platform and CHAP's vision tools? So actually, we are working hardly on it. For sure, they are, but we can't promise anything for the moment. But we are, actively working on the synergies, for sure. Then other questions from Nicola. So Nicola says, thank you for the presentation, Laurine. How can you be sure of the reliability of the sources? That is a good question, but actually on Geotrend, you can access the list of sources that make the graph coming on. So, and you can choose to delete the sources if you judge that they are not reliable. So it's not like a black hole. You can easily access the sources. So it's quite easy actually.
And just to add something, in Geotrend we have a metric of relevance. Yes,
yeah,
metric of relevance, and we have a first filter of information to be sure that these sources is relevant, and there is a consistent information. Like if you don't have actor, entities, or relationship in this document, this is less relevant for us in our analysis.
Okay, another question from Nicola. Thanks to an example you can choose, how can you transform a visual information into a strategic decision process? I think it depends a lot on your strategic, decision-making process in your company. I mean, it's for sure an aggregation of different kind of information that help you to make a strategic decision. I don't know if I answer the question, but for me depends a lot of different aspects on your own goal, objectives, and so on. Laurine, do you want to add something?
I agree.
Okay. What is the maximum keyword you can put in your Boolean queries?
Okay, I take it. You can put around the 12 keywords is a consistent query. However, if you need to put more keywords, it's totally possible, as you can combine cartography together. So you can do all the cartography that you want, and after combine all the results to have in just one cartography all the data collected. And then you have another way to do your research. If you have a lot keywords, you can do a research by list and put all your keywords in the list. I imagine your keyword could be a company, a product, technology, person, or concept, project, I don't know, and you can put it on the list, and Geotrend will process all these keywords to focus on, and that's it.
Okay. Thanks. So around 10 keywords, but there is other way to write your query if you want to be more precise.
Yes.
Okay. Yes, Joanne, we will contact you, and actually you all gonna receive the replay and the presentation by email in the next days. How do you see the BACs brought by the language? Can your search in English hide some actors? There is two questions in one actually, but it's interesting.
So English is basically the international language. So there is not high risk that we lost information with the search in English. Maybe I won't answer this if you ask me if I did my research in French. But with the English, you can be sure that you collect all the relevant information. Can your search in English hide some actors? It could be, but it won't be the majority. Of course, if there is a small startup just beginning in Italy and just communicate in Italian, you won't have this information, but you know it. Like, it's your disclaimer, you know it, and you do your research with this knowledge, and if you want to be sure, you can do also your research in Italian or Spanish or in German, as we can.
Yeah, hopefully we can query also in other European languages, Chinese and Russian too, for example, and you are able to merge the different searches you did in different languages. Then you have the global and complete view of the ecosystem you are analyzing.
Yes.
So Gregor's gone is back on the time you spend to do the presentation. So Laurine, when you said 35 hours is for the research itself plus the presentation, is it?
Yes.
Yeah.
In my private chat, I have a question from Jean-Luc. Yes, this work was totally generated from Geotrend. All the data that you see come from Geotrend.
I also have another question in the private chat. Are the segmentation graphs generated automatically? Example, so you know the graph you have, Laurine, with testing, complex component, repair, or prototype?
Oui, yes.
So the segmentation graph was generated automatically on Geotrend or not?
Not yet. Not yet. You have to use an Excel file or a Google Sheet to treat your data and create this graph. But we work hard. Our technical team work hard actually to implement data visualization. It means that you will have a plug and play graph. So in a few weeks you can do that by yourself directly on Geotrend. And if you are interested in, just to add, I have a specific methodology to create delivery with Geotrend, and I can present it to you if you want.
Okay, then another question. Geotrend, was it helpful to identify low entities or low signal concerning trends for 3D printing?
Yes, Geotrend is helpful for that, but here our study was an exploratory study, so with macro information. It was our decision, as we have just 20 minutes of presentation, so we can't go deeper on every low entities, but you can do that with a specific methodology on Geotrend, of course.
Okay, thank you, everyone. We still have 2 minutes left if you have last questions. Okay, then. So thank you very much to having been with us today. So as I said, you're going to receive the replay and the presentation in your mailbox. Don't hesitate to contact your key account manager or your contact at Geotrend if you have any question. Yeah, and see you soon.
Thank you, everyone.
Thank you. Have a good day.
Have a good day. Bye.